I did a thing with Arcadis in Hong Kong a couple years back, and people came from all over the globe, and I was like, okay, where's everybody from? Just plug that into Lange and coordinates and mapped it over a view of the world. And then everybody flew into Hong Kong from where they were from, which was pretty cool.
So Mark Hayworth, 4 seasons in a day, woke up to snow. Now it's bright sunshine and there's a cloud, but that's raining. Wow, that is. And then we got Thomas is in Germany, rainy and storm.
Yeah, Mark, this sounds quintessentially British. I lived in Glasgow for 3 years and London for 2 years, so I've experienced the same thing.
Awesome. We'll give you just another minute here before we'll kick it off. If you could just shout out where you're from in the chat, we'll figure out who is the furthest away from me and has the best weather or the most complex weather. Is there anybody in a hailstorm? Chicago. Hey, Paul, good to see you here. Gloomy and gray. I guess that depends on where you're at in Chicago, right? All right, let's kick this off. Welcome everybody. Want to thank you for joining us today for the community conversations. Our community conversations are a new live virtual events designed to allow you to gain expertise. In these new live virtual events, you connect with leaders and grow your community network. My name is Sean Hurley. I am the community host. I'm the community engagement manager here at Autodesk. And I am joined by 2 fabulous hosts. Please introduce yourselves, Jacob and Saul.
Sure. So I'll go first. My name is Jacob Small. I'm a designated support specialist for Autodesk out of our Boston office. My specialty is BIM and generative design. Been with Autodesk about 3.5 years now. And Sol, you want to go ahead and introduce yourself?
Hello, everyone. My name is Sol. I'm the Dynamo product manager, so responsible for its evolution and growth as we move forward. And today I'm going to be the co-pilot to Jacob's pilot as we walk through some pretty cool stuff. Been at Autodesk now for about 2.5 years, going on 3 years, ex-architect from my previous former life.
Thank you. All right, let's get some ground rules. Everyone's line is muted to reduce the background noise. We do invite you to turn on your cameras. Kind of gives us a physical feeling of the community conversation. This is community, it's not just one directed. And with that, raise your hand using the Zoom toolbar or post your questions in the chat and we will get those as we can. This session is being recorded and will be emailed to all attendees and uploaded to the community conversation site. So again, this is community. This is a dialogue. We're going to learn some cool things. With that, let's move to the next, please. Lawyers always have us, let you know that the things we say that are anything forward-looking that's not in the shipping product, don't make your decisions or purchase decisions based on anything that's forward-looking. It's what's in the product right now is all we can guarantee. But we have some great ideas. I've got 2 great hosts that would know the future of Dynamo, but the lawyers just want us to make sure that you all understand that all we can guarantee is what you have today. So next, please. Our community conversations are the previously hosted customer success meetups. We aim to provide opportunity for engineers, designers, artists, and makers to meet in a safe, live, virtual setting to share expertise, get to know other leaders in their field, and grow your community network and to learn some things. I mean, this is the great benefit of it. You utilize your network, and there's a great amount of talent and expertise here. In this space, we'll bring you expert speakers like Jacob and Saul, as well as many others. That could be Autodesk employees, customers, partners, students to gather around knowledge sharing, where questions and discussions will be sparked and hopefully forging new connections. With that, I will hand it over to the, we have Sorry, I was not prepared for this slide. Our community managers host various other community conversations. So go to the community conversation page that we'll provide at the end, and you'll see a bunch of other ones. Revit, there's AutoCAD electrical, all kinds. So get involved with these. It's not just the Dynamo one.
All right, and I guess we'll take it over from here. Thanks, Sean. Great intro as always. Let's kick it off. So this session is all about geometry modification. So we talked previously about different abstract geometry types from vectors to coordinate systems. Then we got into physical model types that we actually see and represent real world things like a sphere. And today it's all about, now that we've made things, let's see what we can do with them. We are going to try and limit this to a particular section of the library, and we'll get into that a little bit more once we get into the demo. But so we got the 15-minute presentation on geometry modifications starting off. Then we're going to get into live demo. I'm actually going to bounce back and forth between sort of the slides and the demo as we go before building up something that I hope is going to be a pretty fun sort of build live in real time. And then we'll have some question and answer time to fill out the rest of the time. So without further ado, let's get started here. So our first node to go over is translate. Translate is a sort of computational design speak word for move, right? There's three different ways to translate geometry in Dynamo. There's XYZ components, by vector, or by vector and distance. And one thing that you will note, and I'm going to demo this in a minute, is all geometry modifications basically modify the existing thing, but don't destroy the previously existing content, right? So our as we build stuff up, it's sort of a non-destructive method of building up these different pieces of data. The previously existing data still persists, so you can always go back to that. Sometimes this is good, sometimes this is bad. You sort of have to really take that into account as you're building up your content, specifically around your geometry display. You may find you want to turn stuff off as you go. So feel free to add in anything else while I spin up over here and launch our first demo.
Right. So I just wanted to add that if you've been paying close attention to the last couple of sessions that we did, there is a speed difference between creation of abstract geometry and creation of physical types. But there's also a speed difference when it comes to taking an already created thing and moving it to a new place. So the ability to take a created sphere or cube in this case and move it to somewhere else is going to be a little faster than it is actually creating that cube in another place too. So if you're looking to replicate geometry across different places, utilization of these abstract methodologies such as translate will actually net you a speed gain in Dynamo as well.
Cool. So the specific section of the library we're going to focus on today, because any particular geometry type may have its own sort of modifiers. So if you go into curves, there's a way to modify curves. If you go into surfaces, there's a way to modify that. But the session today, we're going to just focus in real tight on modifier section under geometry. So geometry, modifiers, geometry primarily. And you'll see all the different nodes that we're going to sort of cover today are listed out in here. We're going to start by going over these translate nodes, and this is going to really demonstrate kind of what we mean when we say non-destructive. So I've placed my first cuboid here. You can see what happens when I select it. It gets that sort of blue highlight. And now I'm going to move this with the geometry translate node on an XYZ value. So let's move this on the X axis by just 12 units. We wire that into the X. 12 units might have been a bit far based on how I was looking, but you can see I now have two cubes, the one that I've moved and the one that was previously created. So this can be really, really useful because I can always go back here and reuse the previous cube, or I can continue to manipulate the geometry that I created before. The next method of translation is by just direction. So in this case, we'll take the cuboid, wire this in, and this needs a direction. You can see when I hover over it, it says I need a vector. We can quickly make a vector by coordinates. We'll move this on the y-axis by, I don't know, 10 units seems like a good value. And you can see once again, another cube was created, this time up here, right? One more cube that we're going to try and make here, and we're going to leverage the last translate method, which is by direction and distance. So as opposed to just saying, what's the path that you want me to move this shape, or how far on the X, how far the Y, how far on the Z, this is going to say, take that geometry on a given path. We'll move this on just the Z axis. And how far would you like me to go on that path? So let's move it by, I don't know, 5 units seems like a good number because that's where my finger landed. And you can see we've now created a fourth cube. So now I have 4 different cuboids, but I can always go back to any one of those and manipulate that one. So rather than manipulating the first one, I wanted to manipulate this one. Whoop. Helps if you wire stuff into the right data type. You can see we can move those different pieces around. So that's what we mean when we say non-destructive. All right, I'm going to leave this up on screen now, and I'm also going to change this to be a little bit narrower of a value. Let's go to 0.75 on my X, Y, and Z values. You can see how those two pieces sort of pull together. And then I'm also going to do one last piece. I'm going to wire this in so that we can sort of see these pieces in our sort of different colors. So let's actually take a quick list here, A and B. And I'm going to wire this in as index A and this in as index B. And this should allow us to a little bit more easily visualize the different geometry shapes as we can continue to get into our different modifier types. Just color one piece of geometry one color and the other piece of geometry the other. This was done with a simple color by our alpha RGB value nodes and geometry color by geometry color node. All right, so our next piece is split. Split is basically going to take 2 different pieces of geometry that interact in some way and pull them apart into sort of separate pieces. So this is how you get a hemisphere from a sphere, a grid of squares from a surface, overlapping segment from non-overlapping segments, so on and so forth. It is going to give you both halves of those 2 individual pieces. So it's not just the pieces that overlap, not just the difference. It's going to give you kind of the combination of the 2. So to do this, we're going to take those 2 nodes that we had before. I'm going to come back into our geometry library, right? So once again, we're under geometry, modifiers, geometry. We'll pull out the split node. And I'm going to take our first cube, which I've named A, that's the blue cube, and our second cube, that's B, and we're going to wire that in as our split. We'll turn off the preview on this, and then I'm going to wire this into here. And you can see this is now coloring the 2 sort of individual pieces. Now it can be a little bit hard to understand where stuff came from. So I'm going to do one last thing here. I'm going to take my list of A and B, and we're going to quickly pull the edges so we can sort of visualize where stuff came from. And then from each edge, pull the curved geometry. So these were the original outlines of those 2 cuboids. And you can see the piece that is now remaining in that sort of red sphere among those 2 is the piece that is kind of overlapping where those 2 pieces set through. Let's actually disable the translucency so we can see that a little bit clearer. Hopefully that makes some sense. Anything to add to that one, Saul?
Just one thing, which is you'll notice there's multiple different ways to do things inside of Dynamo. So in terms of the translation that Jacob showed earlier, there was 3 or 4 different methods that you could use to do that. And they are all useful in their own right in different ways. And it doesn't matter which one you use, so long as you get something that gives you the result you want. But sometimes it's better to do it with math, with vectors. Sometimes you might want to just give it pure numbers when it comes to XYZ translation. So that'll be a common theme that you see with multiple of these different modification methods that come through in Dynamo. There may or may not be multiple different options that you could choose to use that best fit the problem you have at hand.
Cool, well said. All right, so next up, we've got intersect. This is going to get us just those 2 sort of overlapping pieces. This is how we get just sort of a lens from 2 overlapping spheres like we see here, a polyline where a polysurface might intersect a plane, a surface from the middle of a solid. That's actually a really great way to quickly pull a section. If you had a complex geometry, build a plane, intersect that plane with the larger solid. Let's take a look at that. So that's the geometry intersect node next. So I'm going to go again, once again, in my geometry menu under modifiers, we're going to go for the intersect. And I'm just going to disable the, we'll just actually wire this over. No need to disable previews yet. We're going to take shape B, which is our red cube, the upper cube, and shape A, which is the blue cube, the lower cube. And notice I now only have 1 cube remaining, right? That's shown right down there. And you can sort of see how that sort of laid out. And the reason for this is it's looking at just sort of the combined pieces of geometry that are common amongst the 2 pieces, the geometry and the other that were input into this node. All right. On to DoesIntersect. DoesIntersect, it's basically the way I like to describe it, it's built-in clash detection, right? Because everybody likes to make sure that their model is sort of coordinated. So no new geometries are actually created with this one. It's just going to tell you if the two pieces touch. So we'll come back here and we'll take our does intersect. Here we go. And again, this takes our initial geometry. We're going to take cube A, originally it was the blue, and cube B, originally it was the red. And then you can see it just produces a quick true or false value. So in this case, the two pieces touched. But if I came back here and I modified this cube that I moved, sort of the red cube that we shifted out of space, if we moved it by 2 units instead of 0.75, the two cubes are now sort of located a bit further away, and you can see they no longer touch, right? So there is no intersection. That Boolean is now going to return false. I often see this used in combination with a list filter by bool mask, where if I had a bunch of cubes on space and I wanted to know which of the cubes might touch this other shape, we could quickly do a does intersect and then do a filter by Boolean mask to pull the content out that just intersects the shape that we're targeting. Anything to add to that one, Sol?
Yeah, so if we're talking about things like clash detection, a real world application of this would be you really want to use these abstract types, right? And this does intersect could be considered as an abstract type first before you try and connect every single thing to every single thing. So it's kind of like a filter or a pre-event. And what you want to do is go and collect only the relevant things to each other. So you can see if only things intersect, and then you can potentially join those geometries and say the Revit space, or you can make sure you can do some sort of downstream Dynamo operation with them. So what you don't want to do, or what you want to avoid, conversely, is trying to do every single thing to every single thing all at the same time, because the bigger your problem space or the more geometry that you're using, the slower things are going to get purely by the nature of it having to compute those things. So if you pre-pass them and you say, I only want to get the things that are touching to do something with, I don't need Dynamo to even consider anything else. You just do a filtration event on this with a list up by filter Boolean node, and then you can only work on the actual things you care about at any given time.
Cool, well said. Next up is explode. Explode is pretty much what you might be used to in AutoCAD or perhaps even Revit if you're doing some CAD imports, where we're basically going to pull the core components that make up the geometry. This allows us to sort of expose sort of the primitive pieces that make up sort of the larger, more complex shapes in a pretty direct manner. I use it pretty often for stuff like, pulling the, if I'm not sure if I'm going to have a surface or if I'm going to have a polycurve or a cuboid, we can always just do a quick geometry explode and sort of quickly understand what that thing is made up of. Once again, looking at how that works, we'll take that geometry explode from that same section of the library, and we can explode an individual piece, which looks like this. Now, when I wire that in down to here, you can see we're going to color each one of those cubes, faces of the cube, a different color, varying from very blue at the top to very red on the backside, right? So that's sort of the order that those cuboid faces were created. If we did want to do this on sort of a larger sequence, we could wire this in. But notice I'm now coloring one cube blue and one cube red, even though if I look at my data preview, this is a larger set. And that again comes back to our list structure, right? So if I look at this, we're lacing all of my red color gets mixed with the first item in the list, and all of my blue color gets mixed with the first item in the list, all of this stuff. And then all of my red color gets mixed with the second list, all of that stuff. So if we wanted to individually color those faces, we'd have to use those flattened nodes. And this is why we covered some of that other sort of core list management stuff. Whoop. One more right click there. This is why we covered some of that list management stuff before we got into sort of geometry manipulation, because it's really tough to do a lot of stuff if you don't have sort of that understanding background of where stuff comes from. Anything to add, Sol?
Yeah, so geometry explode can be really useful just to get down to the baseline components, like Jacob said. So if you have a NURBS curve or a polycurve, in this operation, you should be able to explode these into some baser components. And sometimes you'll get what's called just like a curve, which is the higher geometry class inside of the curve space. And to get from a curve to something real, you probably want to use the geometry explode node as well.
All right, on to mirror. So we're going to go through a couple sort of modifiers now that are really similar to what you might be used to seeing in your CAD and Revit sort of command base. So mirror, basically you just define that what plane you want to mirror about, and it's going to take the geometry and create a new copy of that geometry on the other side of that plane. Unlike Revit, there aren't as many concerns as you might have in your typical BIM world, right? I always get upset when I see somebody mirror a plumbing fixture because now my hot and cold inputs are on the wrong side of the fixture. The flushometer's on the wrong side. That leads to ADA concerns, accessibility concerns and stuff like that. So definitely one great thing about sort of being in the conceptual environment is you don't have to worry so much about that. But the way this node works, I'm going to go ahead and place one of them on the canvas. You can see it here. So it takes our initial geometry, but to use this, we also need that mirror plane. So I'm going to take the list of both geometries, wire this into the flatten. I'm also going to turn off the preview on this. And I now have to quickly build up a plane. And if we remember, planes are under our geometry abstract section of the library. We'll build one by an origin and normal. It automatically uses the default input, but let's go ahead and create a point by coordinates at, I don't know, -5 on X and -5 on Y. We'll use that as the origin, and then on normal, we need a vector. And we'll do -5 on Y and Z. Now, when I look, let's actually change that to here. So you can see how that sort of places that location. And now I can wire this plane up into my geometry mirror node, and the two cubes get sort of flipped right over to the other direction, right? So this can be really, really useful if you have larger sets of geometry that you just want the inverse of, or if you only want to model half of something, just like in sort of the CAD days where you might sort of perfectly trace out the right side, and then let's go ahead and mirror that over and get the other side of the Corinthian column or whatever else you may be modeling. Anything to add, Sol?
Yeah, just like I added previously, a mirror event will be better than creating this again from scratch. So instead of copying and pasting all of the nodes up top that Jacob used to create the geometry in the first place, and then trying to make sure that's created in the mirrored location, simply using geometry.mirror is a more effective action in terms of resource consumption inside of Dynamo.
Yep. Cool. Next up, we've got rotate. Axis or rotation is really, really important here. And it's a lot of times people just don't understand that they've always been defining the axis of rotation in their other applications, right? If I go to mirror in Revit or go to mirror in AutoCAD, it's typically gonna, or sorry, rotate, not mirror. It's typically gonna assume that the axis of rotation after I pick my rotation point is perpendicular to the view, right? It's gonna take the view that I'm currently looking at and say, perpendicular to this, about that point, rotate the thing. We don't have as much of sort of an option there for that in Dynamo because there isn't really a hard-coded view. The view is derivative of the model content that's been sort of pushed through. And so as a result, we have to define what that axis is. So there's actually another rotate. We're going to show both. I'm going to start with the rotate by base plane because I happen to already have a base plane here. I'm going to turn that on so it's just on the Z-axis. We'll set that to positive too, just because that's how I think. So you can see the plane that we've built here. I'm going to use that as my base plane, and we're going to rotate by 90 degrees about that plane, this geometry. And we'll wire this down into here so we can sort of see how our cuboids rotated around. And you can see there's 90-degree rotation. Former blue cube was over there, now it's over here. Red cube now is over there. And then the similar node, if you didn't want to take the time to sort of build up a plane, there is also this node, and this is the one that I sort of illustrated. We take our geometry, it takes an origin, it takes an axis, and it takes a degrees setting, right? So we're using, you can see I literally reused the same stuff that I built that plane from. Dynamo's just sort of simplifying the content that's been provided. And yeah. So there we go. Anything to add there, Sol?
Nope, I think conceptually these pretty well make sense to most people who work within the AEC space. Rotation is rotation. All you're doing in Dynamo is you're actually having to define, like Jacob said, all of the input variables to say how your geometry rotates. In the case of mirror, how your geometry mirrors, and all of the other modifications of geometry we have here. It's a little bit more granular, but it does give you really high degrees of control as well.
Cool. All right, and then next up after rotate is scale. Oh, we've got a train wreck, sorry about that. So you wanna be real careful about the version of scale that you sort of pick out. A lot of times the scale node is going to default scaling about the internal origin, the hard-coded 0, 0, 0 point. You can see that sort of happened here where we took a point at the x-axis 5, y0, z0, right? So right here, put a sphere around that, scaled it up by 5 units, and now the center of this ellipsoid is actually 5 times 5 away, 25 units from the origin as opposed to the previous centroid. One handy fix for that we'll show off here. So I'm going to take the scale node. We'll take just this one to start with. We'll take our original.
Well, Jacob, I think we've lost your voice.
Yes, he went quiet.
I must have muted myself. Sorry about that.
No, I'm so sorry. That was me. I was letting someone in and I did that by mistake. Sorry.
That's fine. Hopefully we can all hear me now. So what I was saying before is we're going to start by just sort of scaling this piece up. And again, you can see these have now sort of completely engulfed the previous shapes. I'm going to use a smaller number. Let's go 0.25. And now you can see it's still scaling about that origin. If we wanted to scale the cubes about their centroid, we'd have to use a different method. For that, I recommend this node, which takes our geometry. We'll take our list of cuboids, takes a plane, and we can quickly define our plane by origin normal. Now it does need an origin point. What I use for that is the solid.centroid node. And this will take the centroid of each of those solids. We're using our sort of list capabilities of Dynamo to make sure we return both individual pieces, use that as our origin, and now use that as our plane. And we're going to scale about that individual piece. So now when I type 0.25 on my X, we're scaling it on just the X value by 0.25. We could scale it by, I don't know, 2 on our Y and some other number. That's too big of a number. I meant to put that decimal point much earlier on our Z amount. And then this content can sort of move itself the rest of the way through the larger sort of portion of the graph. So you can see how that all worked out. Next up is trim. Trim is going to be sort of similar to our split command. And I actually recommend sort of learning how to use the split command a little bit better first off. So we're going to start by clearing up our canvas a little bit. And then we're going to pull the trim node on the canvas. So the order of inputs absolutely matters, both in terms of the geometry and sort of the point and where that point sort of sits. So you may find that you wind up using, origin points or centroids of solids or minimum or maximum points of the object bounding box or vertex point. But it's really, really sort of key to sort of manage that content the rest of the way through in terms of how it works. So we're going to take our A geometry as our first piece. Our other piece is going to be the B. And then we need a pick point. I'm going to use the solid.centroid node once again. And I'm going to use this on the B geometry. And now you can sort of see the shape that this took. It bit that section out, right? If I used a different point, if instead of B's centroid, if I use the A as the centroid, it's going to remove the other piece because it's going to remove the piece that's sort of closest to that other piece. All right. Any question or anything to add on that? I see there's some content in the chat. We'll get to that in just a second. I think we might want to talk about that a little bit live as well. So Thomas, if you want to come off mute, if you're okay with that, feel free to raise your hand and we'll get you added in here. Last piece to cover in terms of everything before we get into the live demo and Q&A is distance 2. Distance 2 is going to give you the minimum distance between any two solid body objects, right? So if you've got 2 points, it's going to tell me the distance between the points. If I've got curves, it'll tell us the distance between that. If I've got solids, it'll tell us the distance between that. So I've got 2 spheres here, tells us how far apart those 2 are. I often see this combined with list lacing. It's very frequently used in generative design workflows. Once again, we'll scroll up in our library and pull that out from under the geometry modifier section. We'll take cuboid A and cuboid B, and our cuboids touch, so we've got a distance of 0. But if I start to extend that distance, set that movement distance to 2, you can see that value is 1.73, right? And what actually happens, and this is another great node that's not in my PowerPoint presentation, but closest point to, we can take our AB points as one set, and I'm actually going to then make our VA list, so the reverse of the other list, as the other set, and it's then ask, what's the closest point between these 2 points? And if I turn off this preview and my solid centroid, there you go. You can see the 2 points that I created are there and there. And those are the points that are closest between. And sure enough, if I quickly build a line by best fit through those that list of points, and then say curve.length, you can compare those 2 distances, 1.73 and 1.73, we're getting the exact same piece. So we could do this geometrically like this, but it's definitely much, much faster to just use that distance 2 node. Anything to add to that one, Sol?
Nope, those last 2 are pretty well covered.
All right. So Thomas, I don't know if we got you unmuted or not, but.
I'm unmuted, yes, but
awesome.
I have no headphones selected. Okay.
Cool. Well, we can hear you loud and clear. So you had a question on IFC geometry.
Yeah, my question was if you can easily import or kind of link into Dynamo IFC geometry, because you said with the clash detection, and I was thinking about the piles, the boring parts, yeah, and the surface or something. Sometimes that's the IFC file and would be okay. I can import SAT, of course.
Yeah, you could take your
but without going the step to Rivet directly into Dynamo. Is this possible?
Yeah, you could potentially skip that. I know there's a lot of interop to sort of pull IFC data out to other forms. Sol noted that you could go to perhaps SAT and other formats like that. I'm not sure of a direct IFC read package. You might want to consider going into Navisworks instead of Revit, because we can quickly append that, and you can use Dynamo to sort of do some of that additional sort of comparison as well. But I think if it was me, I would probably take the IFC, because I know I'm going to want to do more. Like every file I get, I'm not just going to want to constantly refer back and go to like a geometry conversion. I want to convert it into the format I do the bulk of my authoring in Revit once. So I'd probably just take that IFC and convert it to RVT, save it, and then just refer back to that every time I might want to refer to it, and update it obviously as changes have make their way in. So that makes sense?
Yeah. Yeah, the maybe a good use case would be if it's a very large IRC file and you just want kind of the landscape and not the whole building. And then you can just maybe filter with Dynamo just the landscape. So you don't have to import everything, just what you need.
So we're going to get real deep into the weeds on what makes up an IFC file here real quick. They're basically really big text files. So anytime you have to read information out of a document, you have to open the entire document. So if the file you received is the entire building, the landscape, the structure, the mechanical, electrical, the plumbing, and everything else, you're reading in literal textual description and whatever IFC reader you might have, the entire contents, and then you're going to have to sort of filter it down. If it was a really big IFC like that, it's definitely going to be simpler to sort of do that filtering using Revit, where we've got categories, or sort of other sort of methods, I think, personally, than going through and trying to use the IFC raw data as received.
Cool. I would just add to that, like, sounds like a great opportunity for someone to create an awesome IFC interop package if it doesn't exist already. I personally I'm not aware of any IFC interop package, similar to say Geometry Gym is and other spaces, but there's options there if somebody wants to go down that path for sure.
Yeah. right, let's get into the live demo because I have some fun stuff we want to show off today. All right, I'll go ahead and save this, and we're just going to start a brand new file from scratch. And if anybody has any questions kind of as we go, just put them in the chat, raise your hand. We can sort of talk through stuff as I sort of build stuff up. I'm going to try and go pretty quick through some of this stuff, but I'll describe what I'm doing as I build it up. So the first thing I'm going to do is I'm going to build some points by coordinates. I'm going to do it on just the X and Y axis. We're going to do this building a range from 0 to 100 with 10 steps in between. And when I do this, I'm going to wire it in to my X and Y value. And notice I'm just getting a line of points. And that's because I have to first change my lacing to cross product. And with this, I now have this sort of 10 by 10 grid, right? This 10 by 10 grid is going to sort of form the basis of my larger design piece. And you can see sort of the list structure that's been set up there. It's 10 sublists of 10 points. Next up, I'm going to take a number 10 and I'm going to use a list.ofRepeatedItems node. We're going to take the number 10 and repeat it 10 times. And I'm going to use this to generate some nice random numbers. We're going to use a math.randomList node. And since I have 10 groups of 10, I now have 100 numbers in groups of 10, just like I have 100 points in groups of 10. Whoop. But these numbers are kind of small, right? They land somewhere between 0 and 1. So I'm going to do a quick multiplier to those. We'll multiply these by -10. So these numbers are going to be lower than 0 in all cases. And now we're going to start to use our first geometry modifier. That's our geometry.translate node. And I'm going to translate my initial set of points on the z-axis by that value. And now I've got something that looks kind of interesting, right? So we've got this thing that looks maybe like a really loose point cloud of sorts. Well, now, since I've got that in that sort of list structure, we can start to build a new type of shape. We're going to go into our surfaces, NURB surfaces by control points. And now I've built kind of a topography sort of shape. And that looks pretty good. I want to now do a little bit of cleanup on my piece here. We're going to hide all that geometry preview. And I'm keeping an eye on the chat too. So if anybody has any questions, again, feel free to speak up. With this individual surface, let's try and get a good color here. We'll use a geometry color node. And we're going to set a color to 255. So I did use, I don't know if anybody saw it, I did use the node autocomplete feature there to just quickly grab the color that I was after. So by holding down Alt and clicking, it pops up sort of the common input. I'm going to use the number slider for this as well. Set this to, I don't know, 128, halfway translucent. And we'll turn off this preview so that we can just see my translucent landscape as it may sort of fall through. And now with this, we're going to start to look to populate some stuff. And the thing that I actually want to populate is some fun cubes. So to do that, I have to first build up a cube. So we'll pull this node down here to give ourselves a little bit more shape. And I'm just going to use a cuboid by width nodes. Keep it very, very basic. I don't know, dimensions of 2 seems good. Right? And you can see I've got this cuboid and it's all the way down here at the origin, right? Now, we mentioned this node, in particular, the geometry.transform node previously, and that's what we're going to actually leverage here, kind of at the high level to make sure stuff sort of really syncs. So what I'm going to do is I'm going to say, let's go ahead and build a surface coordinate system at parameter node. I'm going to take our surface here, and I'm going to build a range from 0.1, because I want to hold it a little bit off the edge of the surfaces, to 0.9 on my U value and my V value, right? And we see that sort of pull through. Notice I'm getting just sort of one piece. Let's set my lacing to cross product. think I may have.
You need an amount.
I need an amount. You're right. I need to say I want 10 of these because as it was written before, it was just giving me just the one number. There we go. So instead of just giving us 0.1, we need to say, give me 10 values in between those two steps. So now you can see we've got those 10 shapes all in a row, and I now have an entire field of coordinate systems. And you can see those z-axis, the blue sort of lines, are following sort of perpendicular to that surface. So whatever that was, if I had a different random shape, we're going to get different z-axes, which is pretty cool. All right. And Sol mentioned before, you know, the idea of rebuilding content is often going to be slower than just taking information from content. So what I'm going to do, I'm going to flatten this first. So we've got sort of a fresh place to start instead of having a nested list. We've just got those individual values. And now we can come into our abstract menu. And what do we know about coordinate systems? One of the things we can query from them is their origin. And now I can take that origin, and this is an actual point, it's a geometry piece. I can now go back into my geometry modifiers menu to take the distance from this point to another point. And it's actually this list of points. So let's build a quick point by coordinates node. You can, once again, just keep that on the XY value. And I'm going to keep these values between 0 and 100, but for now, I'm just going to set them somewhere in the middle. And we're going to use this as an attractor point to sort of deform those values. So I can take this curve, this point, and sort of move it anywhere within the domain of my landscape. Right. All right, now I'm going to do a quick bit of remapping of our range. So we're going to use a math.remapRange node, which takes a list of numbers and sets the values between what they were before and a new number. So I'm going to set this from 0.5 to 5. And this is going to allow me to get this sequence that's now the biggest distance that I have here is 5. The smallest distance that I have is 0.5, right? But I'm going to do this not for sort of one individual piece. We're going to actually do up a series of these. So 0.5, 0.01, and 10 as my first minimum. And my next list is going to be 5, 0.99, and 255. The first list of numbers, right? So I've got 3 lists of 100 numbers. The first list I'm going to use for scaling. The third list is going to sort of define my color. And the second list is going to define the radius of some additional deformations that we're going to make. All right, so now with my coordinate system that I've created before, let's go ahead and we'll take that coordinate system, just checking the chat real quick, nothing in there. We're gonna scale up that coordinate system back under coordinate system scale. Wrong scale. By base point, no, still the wrong scale. We'll use the plane. Take our coordinate system, take its XY plane, and then I'm going to scale it up by that first list. We're going to pull this out of that list of numbers, wire that in. And we'll do that on, actually, let's do that just on the z-axis so that we can sort of really see how that scales. So now you can see that blue line gets longer as we move further away from that point. So what I'm doing is I've built this as an attractor point, so we can start to deform what that value might want to be. Final goal is to populate some shapes through this landscape. And you could think of these shapes as trees. I think of these shapes as things suspended in Jello because that's just a little bit more fun for me. But whatever you might have that you want to just sort of populate through, that's what we're sort of building out. So now I'm going to take my cuboid and take that coordinate system, and I'm going to use a geometry.transform node. I'm going to use this one. It's once again under the geometry modifier section. So it takes the geometry as an input, feeding it one cuboid in a whole list of coordinate systems. And notice how these are now sort of always perpendicular to that original surface. And they're scaling up in terms of their height based on how far they might be to this attractor point. So if I move this attractor point around, my cuboids quickly change shape based on wherever I might put that. I'm gonna go ahead and turn off some of this other stuff so that we can see this a little bit more clear. There we go. Now we can continue to use this geometry. We can continue to modify it. So the next piece that I'm going to do is let's try and sort of flatten this stuff out. I'm going to go ahead and fillet this. So you can fillet a solid, which is pretty cool. It takes a geometry. It takes a list of edges and a radius. So I've got a radius down here. I'm going to use that as a bracket 1 in this list of numbers. This goes in as my radius. And now I need to get edges. Topology.edges. And if I hide my previous transforms, notice I'm getting rounder as I get further from my attractor point. Right? Now, the next step is let's try and get this some color. We'll build a geometry color node. We'll take our individual solids. And then I've got one more node down here in this math remap range. Color by alpha RGB. This is going to be our R. List.reverse is going to be our B. And this wires into our color. And now you can see taller, redder, and rounder, shorter, squarer, flatter, and bluer for the ones that are further from our attractor point. And that's how you can sort of build some content up and utilize geometry modifiers all throughout that larger graph. And we built it live in, what was that, 15 minutes? 20? I wasn't really paying attention to the clock.
So if anyone has any questions on what Jacob has just live demoed right now, please do feel free to reach out. Put up your hand, ask the question, get a little bit more context. What we've tried to do is we've tried to cover a series of different modifications to geometry, sort of live, so you can see how long it could take if you're a master like Jacob is. Might take a little longer for someone like myself or someone else, but it is fully achievable and should work in the same kind of sequence of events that Jacob has demonstrated today. So we have one question from Jan. I try to split a solid with geometry.split recursively. Is that a custom node?
Yeah, I think, if I'm not mistaken, that's in Springs. Yeah. I don't have that installed in this particular Dynamo instance. What sort of issue were you having with, were you trying to break some stuff down?
I thought I put a file into the chat, but I missed that one. I tried to split a solid in squares and rectangles, and I succeeded apart, but in the beginning I have 3 and not all rectangles. I select all the vertical faces of the solid, and then he split it. I tried to, wait a moment. Opgeslagen split, yep.
So I often find that a lot of times people leverage custom nodes that they don't necessarily need to. So split recursively is one of those, many times there's an absolute need for it. but in some cases, you can actually get by without it. So I'm gonna try and see if I can reproduce your issue. So I actually need to start at -50 and go to 50 in this case. So you wanna dice one thing up by a whole bunch of different sort of cuboids. I'm gonna step by not 1 because that's a lot of cuboids to sort of calculate. I'm gonna step by 10. And I'm going to use this as my piece here. And let's take our normal as vector dot z-axis, vector dot, actually, let's do vector dot by coordinates. 1, 0, 0. So that's our x-axis. 0, 1, 0, y-axis, 0, 0, 1, z-axis. Now you can see I've got a whole bunch of planes that I've built. And if you look at our list structure, we've built that content that way. And actually, now that I think of this, yeah. So with these individual planes, I'm going to make a rectangle by plane and width. So I've got a list of planes. I'm going to make the width 110 and the length 110. Crazy grid of rectangles. By patch, we'll turn those into a grid of surfaces. By joined surfaces, we'll turn these into a list of polysurfaces. But first, I'm going to do a list dot transpose. So I've got all my vertical, horizontal, and I don't know, whatever the other direction is of individual pieces. And
solid, you need surface.
Yeah.
There we go. And I need to go even bigger than this. I'm actually just going to go to 1,000. That's huge, right? But we'll hide everything. And now split. And we talked about this node earlier. Takes an individual piece and splits it by another piece. And so when I look at this, I get sort of 3 individual solids. But what I really want is I want to do this by the first piece.
Split you.
Why is that not splitting? I might have to think on this one a bit more than I thought. I do this for generative design applications all the time, but go ahead, Sol.
You could try and intersect all in this instance as well. So you could probably do that back with the planes as opposed to anything else.
The split tool is only cutting by other geometry.
Yes.
Geometric.
Yes, so the split tool specifically requires multiple pieces of geometry.
Yes. And that I don't have.
But you can create pseudo geometry in this instance from things like our planes.
Yeah, I'm gonna have to figure out why that's not splitting. I know it works for a surface, but I haven't actually leveraged this on a solid before. Let me think on that, and I'll see if I can reach back out to you.
Jan, quick question. Was this, yeah, Jan, are you getting a piece of geometry you want to split from somewhere else, or are you trying to create it out of the box inside of Dynamo?
Sorry, again?
Are you getting your geometry you want to split from an exterior source? So from, say, coming in from Revit?
No,
or
I make it, it is in a family.
Okay. I was going to say, because if you just want to generate something like cuboids here, you can just create a single cuboid and translate that in both the X, Y, and Z axes. the beauty of live demos. We figure it out on the fly, and if we can't, we can figure it out afterwards.
Yep. I'm about to say, let's figure this one out later, but I just wanted to check.
And there is the sessions forum too, the discussion afterwards,
Okay.
The comments.
So as previously, like we've posted a couple of different graphs inside of those forums. If you did have any follow-up questions to anything you've seen today, feel free to reach out to us on that. We'll do our best to help you out and help you solve your problems.
Yeah, I'm gonna have to dig on the sort of how to split it without getting recursively. The one issue I find with recursively is the definition of what point you want to sort of use as your remainder gets a little bit more complex as stuff tends to go along.
Yeah, but you can see it is what I managed to do is very strange. I did put it in the Word file, some picture.
Yeah, I'll dig into it a little bit and see if we can. We'll get in touch. I think through the form is going to be the best method for that. I can't see the file through Zoom or anything like that at the moment.
Cool. So if there's no other questions, I think we're coming up to the top of the hour, so we can do our closeout.
Thank you for keeping an eye on the clock because I tend not to do that.
So I'll cover this one. So we've got more sessions coming up. So this series is going to be every 2 weeks, or bi-weekly or fortnightly, depending on which part of the world you come from and how you talk about it. We're going to be talking next session about dictionaries in Dynamo, which is going to be exciting. It's a way to link different pieces of data together and be able to pull those out using keys and values. We're also going to talk about Dynamo graph annotations. And this is going to include a special guest. John Pearson is going to also join us and showcase some of the work he's done with his monocle extension, which is really cool. And then the next one after that is going to be how to plan a graph, how to plan a Dynamo graph specifically. And we're going to start talking about awesome ways to start thinking conceptually about how to better build a graph before you even kick off. So please come join us for all of those. More to be announced as this series goes on.
Thank you, guys. So looking for other ways to connect, Kate has posted some nice links to our Twitter, the conversations, as Saul and Jacob mentioned, the chats afterwards, a link to this session is a great place to ask those questions that we didn't get in here or a sample file. So those are great resources. These are the other resources, the Autodesk Group Network. That's all the global network of user groups, industry-focused communities. There's manufacturing, there's AEC, the Revit, there's the Autodesk forums. Follow and engage with us on the Autodesk Twitter, the Autodesk community Twitter handle. Just stay connected. This is a community event. That's all of us here, So let's try and stay connected and engaging here. So thank you. And I look forward to seeing all of you at the next event. Spread the word. I think Kate's going to also post a survey for feedback. So that's all I have.
Yep, you'll get
I'm
that
blown
survey,
away again.
You'll get that survey later in an email.
Oh, excellent.
Not right now. Yeah.
Gotcha.
Thanks, though, Sean.
Excellent. I'm still trying to process a whole bunch of Dynamo stuff there.
I hope it wasn't too overwhelming for you, Sean.
I did get, I'm glad you said Booleans at one point, because I was like, isn't that a Boolean essentially?
Yes.
Yeah.
You've made it, Sean.
If you would have said it was something totally different, I would have went, all right, well, I went down the wrong logic hole. So thank you, guys.
Good to hear. No problem.
Thank you,
All right.
Kate.
Thanks, everyone.
Thank you, everyone, for joining us. Absolute pleasure to hang out with you all. And please come again next time. See you later.
Bye, guys.